Hi everyone, welcome back to the ArgoCD series. We have been discussing Kustomize, which is a very popular and a widely used way to manage Kubernetes manifest and deploy resources in Kubernetes. In our previous sessions, we understood what the base and the overlays directories and how we can use the patch.yaml to apply environment specific configurations. Well, Kustomize is another major approach we can use alongside tools like Helm. Well, this is our SH students config repo to store manifest, and earlier we understood with Kustomize the common approach to have a base directory and a overlays directory for different environments. This means we don't need template directives like we do with Helm. We can work directly with standard Kubernetes YAML manifest like deployment.yaml, service.yaml, etc. and customize them for different environments using customization.yaml under environment directory. We also saw how we can use common labels in customization.yaml so that the same labels can be applied consistently across our Kubernetes resources. In our case, for example, we have label app is equal to SES students. In simple terms, this tells Kustomize to add this label app is equal to SEH students to the resources managed by this customization. So instead of repeating the same label in every manifest, we can define it once in customization.yaml. And Kustomize applies is consistently to our resources such as deployment, services, etc. So if you want to use Kustomize, as we know, Kustomize is integrated with kubectl. So we can use Kustomize directly through kubectl without installing a separate Kustomize binary. So if I run kubectl version, so here I can see my kubectl client version is 1.32.2 and it includes Kustomize 5.5.0 version. So I can use Kustomize directly through kubectl. Now if I run kubectl kustomize base /, here base is the location of our customized configuration, specifically the directory containing the customization.yaml. Here we can see customization.yaml is available under base directory. So this command doesn't deploy anything to the cluster, it simply builds the customized configuration and prints the final Kubernetes manifest to the terminal. So let's see how our service and deployment configuration looks after Kustomize process it. Now, if we look at the generated output, we can see service and deployment resources will be created. Also notice how app is equal to SEH students label has been added to the resources, to the service, also to the deployment, even though we didn't explicitly define it in our individual deployment.yaml and service.yaml files. If I show you my deployment.yaml file, here we haven't defined labels. Also in service.yaml, we haven't defined labels. That's because we defined this label currently in customization.yaml here. And one more important point, since this label is common across our environments, we defined it in the base customization.yaml. So this customization.yaml is under base directory. Then our environment specific overlays can inherit this common configuration and add or override only the settings that are different for each environment. Similarly, we can customize annotations as well. If we want to add annotations that should be common across all environments, we can define them in customization.yaml file inside the base directory. So if I add common annotations and here, for example, I provide version is equal to version 1.0.0 and save it. Now if I run kubectl kustomize for base directory again and hit enter, again we can see that the annotations has been added under the metadata section of both service and deployment. This is for deployment and here again annotations for service. And if we have other resources like ConfigMap, ingress, etc. included in our customization, they will also get this common annotation. So the idea is simple. Our base customization.yaml file contains the resources that make up our application such as deployment.yaml and service.yaml, etc. along with the common configuration that doesn't change across environments such as common labels and annotations. Then our environment specific configurations can be handled separately through the overlays. So next we have overlays sit customization.yaml, which contains our environment specific configurations for the SIT environment. For example, we have here name prefix SIT hyphen. This means all the resources generated for the SIT environment such as the service, deployment, ConfigMap and so on, for our case deployment and service only, will get the SIT hyphen prefix added to their names. For example, if my service name is SH students hyphen SVC, so SIT hyphen will be added and the service name will become SIT hyphen SH students hyphen SVC. Similarly for deployment as well. Also notice that we have namespace SCH-SITIN hyphen ArgoCD UI. This means the namespaced resources generated by this overlay will be created in this particular namespace in the Kubernetes cluster. So now if I run kubectl customize, this time for customization.yaml file which is under overlays SIT, and hit enter. Here we can see that the SIT hyphen name prefix has been added to deployment, also to service, and the namespace has also been updated to SCH-SITIN hyphen ArgoCD UI. So this was a quick overview of customized configurations which we already learned in detail in our previous sessions. Now let's see how to use a config map with Kustomize, which is the real agenda for today's session. We already know that when using plain Kubernetes manifest, we generally create a separate configmap.yaml file. Here under my Kubernetes folder, I have kept the plain Kubernetes manifest, and our plain config.map YAML looks like this. And if I show you the configuration of my Spring Boot application for SH Students microservice, we currently have application sit.properties file, and here we can see DB hostname, DB port. These can be different depending on the environment. Similarly, values such as DB username and DB password can also vary from one environment to another. So instead of hard coding these environment specific values in our application configuration, we will parameterize them. So we will parameterize them like this. So here DB hostname, DB port are non-sensitive configuration values. So we can manage them using a config map. And for sensitive values like DB username, DB password, we should use Kubernetes secrets. We will see it later. Well, that's how we use config map with plain Kubernetes manifest. Now let's see how we can manage the same configuration with Kustomize. For using config map with Kustomize, we are going to use ConfigMapGenerator. As I mentioned earlier, in real organization, database details and other environment specific configurations can vary from one environment to another. So instead of creating a separate config map manifest for every environment, we can define the configuration in the environment specific customization.yaml. For our SIT environment, we will use overlays SIT customization.yaml, and here we will use ConfigMapGenerator. We will provide it a name as SCH students config. Since my application consumes these values as environment variables, I am going to provide an environment variable file here. So here I will mention env and the file name. Let's give it config.properties and save it. So our config map generator will look like this. Let's quickly create the config.properties file. Inside overlays SIT directory here, and we will add our SIT specific values here like database hostname, database port and our active profile. Now if I show you our deployment.yaml file, we are already consuming the config map as environment variable using env from. Now let's see what Kustomize generates. So if I run kubectl customize overlays SIT to use this customization.yaml inside overlays SIT directory, and if I hit enter, you should see a config map similar to this here, and then we will see our service and deployment as well. Notice something interesting here. Under deployment, the config map ref, this thing, Name has automatically changed from sh students to sh students-config and this hash value. So what's happening here? This sit- prefix comes from our environment specific name prefix, and this random looking suffix is a hash generated by Kustomize based on the config map's contents. This is one of the useful features of Kustomize. When the config map content changes, its generated name changes as well. Since the pod template references the new config map name, Kubernetes sees a change in the deployment pod template and can trigger a rolling update. So, Kustomize handles this automatically for us. In simple terms, whenever the config map content changes, Kustomize generates a new config map name with a different hash. That changes the config map reference in deployment, and Kubernetes detects this change and performs a rolling update of the pods. If we need to apply these changes manually, we would run kubectl apply -k option with the customization file location like overlays/sit. But in our case, we are using ArgoCD. So let's see how this works through ArgoCD. Let me take you to the ArgoCD UI. Here we already have our sh students application, and we can see that it is healthy and synced already. If I click on the application and go to details, here under sync policy, we can see that auto sync is already enabled. This means that as soon as we push our configuration changes to Git, ArgoCD will detect those changes and automatically synchronize them with the Kubernetes cluster. So let's push our changes to Git using the usual Git commands. So from here, I will run git add, git commit and git push and hit enter. Completed successfully. Now let's go back to our ArgoCD UI and validate the application. Here we can see last sync a few seconds ago, and the status is processing for now. Later on it will be succeeded. So click on the sh students application to open the resource tree. So here locate the config map and click on it. Under the live manifest, we can see the actual config map correctly running in the Kubernetes cluster. Notice the automatically generated hash in the config map name. This is the hash generated by Kustomize based on the config map content. Similarly, we can click on deployment and check the live manifest. So check its live manifest to verify that the deployment is referencing the generated config map. So this is how we can use Kustomize ConfigMapGenerator together with ArgoCD to manage environment specific configuration and automatically deploy those changes through GitOps. Here we can see that the sh students deployment has been did successfully and we have 2 pods running. Also the application is showing as healthy in ArgoCD. So if we click on a pod, we can see the pod summary including details such as container image and the current state, etc. From the events tab, we can check the events related to the pod, and from the logs tab, we can view the application logs. Now, if we look at the logs, we can see this error. Notice something interesting here. The DB hostname has been replaced correctly with the value from our config map. However, DB username is still appearing as a variable. The reason is that we haven't created a Kubernetes secret for DB username and DB password yet. So Spring Boot is receiving the hostname correctly from the config map, but the database username and password are not being supplied. Now you might wonder, if the database connection is failing, why does Kubernetes show the pod as healthy and running? So the important point here is that pod status and application health are two different things. Kubernetes is currently able to start the container successfully, so the container is in running state. Our application may also have started its web server successfully, which is why the health check on the report is healthy. However, when the application actually tries to access the database authentication fails because the required credentials are missing. So we have pod running, container running, application endpoint healthy, but database connection fails. This is why pod can appear healthy from Kubernetes perspective while the application is still experiencing a functional problem. In a production environment, we would normally make a readiness and liveness probe more meaningful so that important application dependencies and startup conditions are handled appropriately. Now, we need to provide a DB username and a DB password securely. And that's exactly that we will cover in the next session, how to manage secrets using Kustomize. So that's all for today's session. Thanks for watching and happy learning.